Hello, this is Day7 probability, and today we are going to discuss about Monte Carlo approximation. Suppose we have a random variable x and we want to find the distribution of that random variable, distribution of the function of that random variable x, right? So we can we have just learned that we can do this whole thing uh, but there is another way where we can do this thing easily, and this is why Monte Carlo approximation. So what we actually do in this technique is that we generate S samples, right? From this entire distribution we are generating S samples, that is x1, x2 up to xs. Okay, and then we are finding the distribution of f of x. So that means we are finding the distribution for these points, right? So what according to this formula, this method is, suppose we want to find the expectation of fx. So we can do this by using this formula. Okay, but using Monte Carlo approximation, this same thing can be approximated by this formula: 1 by s from 1 to s, and f of xs. So what we have really done is that we have averaged out uh, only on this points. Okay, sorry, this will be f xs, where xs follows the distribution of px. For examples to find x bar. Okay, x bar is nothing but 1 by s from s1 to s xs. Okay, but this thing will be giving our expectation of the random variable. Similarly, for variance of x, we can use the formula 1 by s from s equals to 1 to s xs minus x bar whole square, and this will give the variance. For median of x is given by median of x1, x2, xs. Okay, so the question that may be arising in your head is that whether this technique is uh, appropriate or not, means how much will be the accuracy of this MC. So yeah, definitely the accuracy will increase when our sample size will increase. So with increasing the number of sample points, we will increase the accuracy of Monte Carlo approximation. So suppose the exact mean of a function fx is mu, and Monte Carlo approximated mu hat uh, mean is mu hat, then what, mu hat minus mu is nothing but Gaussian distribution with mean 0 and standard deviation variance mu square by s, sigma square by s. So if s increases, the variance decreases and becomes 0. If s tends to infinity, variance tends to 0. So this will become exactly replica of each other. So, but there is one problem. How to find the sigma? Okay, so if you want to find the accuracy of this difference, then the sigma is given, sigma square is variance of fx is nothing but given by expectation of fx square minus expectation of fx whole square. But the thing is, you cannot find this exactly. So if you approximate the variance, then the formula using Monte Carlo, the formula will become s and fs is minus mu hat whole square. Okay, since exact mu is not possible, we are considering here mu hat. So this will give our approximated variance value mu sigma hat square. Okay, and if you find what is this value, this is probability of mu hat existing from actual mu minus 1.96 of sigma hat by 1 by under root of sample size to mu plus actual mu plus 1.96 mu hat by sample under root of sample size, then it will be given by 0.95%. So it is around 95% of the mu hat to lie in this range. Okay, so and if to find the sample size s, such that the accuracy, uh, the answer should be accurate within plus minus of epsilon, then the S should be more than or equals to 4 sigma hat square by, it is approximate value, okay, by this epsilon square. So if you want epsilon to be very less, then the sample size should be very high. Okay, the dependency is square, inverse square. Let's move to our next topic, that is entropy. Entropy. Okay, so entropy is given by this h of x or h of p. Okay, h of x definition is k from 1 to k, p, where capital K is number of states which a random variable can take, and we are calculating the entropy for random variable capital X. Okay, so the probability of X taking state K times log of base 2 probability of X being state K. So here this is the formula for entropy. Since it is log 2, so we also call this by unit bits, where bits is nothing but short form of binary digits. Okay, and similarly, if instead of base 2 we use base e or ln, then it is called nats, and you can guess it is natural digits. Okay, let's move to next topic, that is scale divergence. What is this? Suppose we want to, suppose there are two distribution P and Q, right? Uh, and we want to compare these two distribution, how much dissimilar these two distributions are. So we give this by KL divergence formula, and it is given by k equals to 1 to k pk log pk by qk. So pk log pk by qk. So you can see it is non-symmetrical, right? By non-symmetrical I mean KL of P is not equals to KL of Q and P. Okay, you can check, and this is this will be only equal when P and Q is equals to they both are same, and this will lead to 0, right? This entire formula will lead to 0. Apart from this, it is not the same. Okay, if we open this log term, then this minus this term. So what I'm saying, it will be equals to minus h of p plus h of pq. This is cross entropy given by h of pq is given by minus for all k pk log qk. Okay, so if you open this term will be known as cross entropy. So this is the formula to knowing whether the two distributions are same or not. You can use scale divergence. Finally, our last topic is mutual information. Mutual information. Okay, so what we really mean by mutual information is that how much knowing one variable can tell me about the other variable. So uh, if something is happening, if some event is happening, so what is the probability that other event may also occur or may also have happened simultaneously. Okay, is happening simultaneously. So yeah, why we need this mutual information? We already can do this by correlation, because if two events, two probability distributions are highly correlated, we can say uh, that both are dependent to each other. But yeah, this is another option, a better way and a better way, right? So it is given by capital I, x, y is by definition scale divergence of p x comma y, this is y, right? And px py. So this joint distribution and this are independent distribution. So how whether these two are independent or dependent depend upon uh, we can show this by using Kiel formula. So if both of them are similar, then this will give us 0 and the mutual information will be 0. If px comma y uh, and px and py, sorry, if px and py are independent events, then px comma y, this will be equals to px py, and then the KL of this two distribution will be 0, and henceforward uh, this mutual information will be 0. So if we open this formula, this will be y p x y log p x comma y and p x p y. Okay, Yeah, that's all for today. Uh, Next, we will be discussing on generative models for discrete data.